The Saturn Service Computer System is the most advanced, integrated, and efficient service computer system in the automotive industry today. It provides complete service operations assistance and control for service management through a complete set of service operations reports and analyses maintained on a current basis and available at any time on the system terminals. Service advisors through an advanced computer-based diagnostic system that helps them prepare a complete detailed customer service order quickly and efficiently. And service technicians through an advanced service stall computer system that gives them major system testing capability, helps them make a complete systems diagnosis, and confirm that a problem has been properly repaired. The complete Saturn Service Computer System consists of 4 major parts. The Saturn host computer is located at the Saturn Communications Center in Auburn Hills, Michigan. This computer maintains all the national vehicle records and tracks the service experience on all vehicles at all dealerships. It does this through nightly transmissions of service records from the dealerships via the Saturn satellite link. It records and maintains all campaign data should there ever be a need for them. The Saturn host communicates with the IBM AS400 dealer host computer, also through the Saturn satellite system. The dealer host contains the 4 major computer programs used to operate the dealership. Sales line, which maintains all vehicle sales and inventory records. Business line, which takes care of accounting and business records, payroll and financing and insurance. SDS parts, which includes all parts inventory and sales records, and has local and national part search capabilities. And service line, which maintains all customer service records, service department operations data, customer service order preparation formats and information, and service and parts sales billing preparation. The Service Advisor System, or SAS, located in the service driveway, is primarily a diagnostic tool. It's used by the service advisor to record customer complaints, develop a preliminary diagnosis, and through communication with service line to prepare the customer service order, or CSO. A key tool in helping the service advisor make the preliminary diagnosis is the Saturn Portable Diagnostic Tool, or PDT. Attached to the assembly line data link of the vehicle, the PDT records data from the onboard computers, including any diagnostic codes or information flags that may have been set, along with actual operating inputs and outputs from the computers. When a preliminary diagnosis is complete and the customer has signed the CSO, this data is then available to the Service Stall System, or SSS, for the technician's use. The SSS consists of 3 main elements. The technician's terminal contains the SSS software and is used to read the diagnostic program and inputs from the PDT. In addition to supplying diagnostic data from the onboard computers, the PDT also serves as a communications link between the vehicle and the SSS computer terminal. The Saturn Basic Engine Analyzer supplies much of the same information provided by a standard engine analyzer and is displayed on the SSS computer terminal. All of these elements combine in the service stall system to give the technician a powerful diagnostic tool to help him service Saturn vehicles more efficiently. The Saturn Service Computer System provides faster, more efficient customer service, increasing customer service satisfaction. At the same time, it makes more data available, faster, to service management and to Saturn engineering. This allows information on vehicle or system problems to be quickly updated and resolved. As a result, Saturn dealer service operations can be run more efficiently and more profitably. As one of the most technologically advanced cars in the world today, Saturn vehicles have from 1 to 3 onboard computers, depending on their option content. These computers perform many operating functions to improve performance, fuel efficiency, and stopping capability. In addition, the computers perform specific diagnostic functions with the capability of recording and storing up to 161 separate diagnostic codes and information flags. These codes and flags are read from the computers by the Portable Diagnostic Tool, or PDT, which will be discussed in detail later. All Saturn vehicles, regardless of option content, have a Powertrain Control Module, or PCM. The PCM, along with the other computers, has a series of inputs and outputs that are identified in the service manual and in the Service Stall System User Guide in diagrams such as this. These diagrams show the specific components and circuits that are monitored and controlled by the computers. If the vehicle has an automatic transaxle, the powertrain control module will include both an engine control module, an ECM, and a transaxle control module, or TCM. The third onboard computer is the anti-lock brake system control module. This module controls the brakes during anti-lock operation and continuously monitors the condition of the system, including each component. The Saturn onboard computers are the heart of the computer diagnostic system and provide the information used by both the service advisor and the technician to diagnose faults and complaints and verify repairs in the engine, transaxle, and anti-lock brake systems. The Saturn Service Advisor System, or SAS, is an important diagnostic tool for the service advisor in the service driveway. The SAS has three hardware elements: a computer terminal on an optional rolling stand, the Portable Diagnostic Tool, or PDT, which records information from the vehicle's onboard computers and records the results of simple tests performed by the advisor, and a printer in a separate stand that prints customer service orders. The SAS terminal performs a number of functions. It contains the Service Advisor Diagnostics program. The advisor uses this to develop a preliminary diagnosis of a complaint in the engine, automatic transaxle, and anti-lock brake system. To obtain a diagnosis, the advisor first attaches the PDT to the assembly line data link, or ALDL, in the vehicle, and selects the Service Advisor test. The PDT can store data for up to 10 vehicles at one time. When the tests are complete, the advisor connects the PDT to the SAS terminal and selects Receive PDT Data. This uploads the test data recorded in the PDT to the diagnostic system. The flickering you see on the screen is not a fault in your TV or videotape. You will not see it when working with the system. A PDT short test retrieves the VIN, option content, and any codes or information flags that were stored in the onboard computers, along with the mileage that was entered by the advisor. At the advisor's option, a longer test can also be run to record additional data. When all the data stored in the PDT has been uploaded to the terminal, the screen returns to the Service Advisor main menu. The advisor then selects Identify Vehicle to pick the specific vehicle on which to enter a preliminary diagnosis and prepare a customer service order. Here there are three choices. The simplest is to select a VIN from PDT data. However, if no PDT test were run, the advisor has to enter the VIN manually on the keyboard. A VIN can also be selected from a list of open customer service orders, which can be called up on the screen from service line in the main computer. When PDT data is in the terminal, choosing option 1, Select from PDT data, is the simplest and the quickest. This shows all the vehicles on which PDT tests have been run, and the advisor can select the one for which he or she wants to prepare a diagnosis and customer service order. This returns to the system main menu again, but this time with the vehicle identified. If a CSO were prepared in advance, such as for an appointment, the owner's name would also be included here. Or when the VIN is selected, the advisor can enter service line and search the service files for the owner identification to include here and on the service order. Once the vehicle is identified, the advisor selects Complaint Entry to enter information from the customer. The first complaint entry screen that appears is Engine, which shows a number of common engine problems on 3 different screens, which are called up by pressing the Page Down and Page Up keys. Pressing F6 allows the transaxle, and F7 the ABS complaint screens to be selected. When a complaint has been selected from what the customer has said and entered, for example, overheats on the engine screen, the computer will display a list of conditions that is used to define when the complaint occurs. Condition screens are available for most complaints listed in the system for the engine, automatic transaxle, and anti-lock brakes, some 530 choices in all. These conditions provide added diagnostic clues for the technician. When all the complaints are entered, the advisor returns to the main menu where he is now ready to create a preliminary diagnosis. The first diagnosis screen shows the complaints that were selected and the codes and flags read by the PDT from the vehicle's computers. In addition, in discussing the problem with the customer, the advisor can select Show Causes on the screen by pressing the F2 key. This lists the possible causes of complaint by fault groups along with the degree of probability of each cause. In this case, a 74% chance that the cause of the engine overheating is the cooling fan circuit. The advisor can also include additional comments for the service technician that will not print on the hard copy of the CSO, but will appear on the technician's service stall system screen when he calls it up. When the preliminary diagnosis is complete, the advisor will be asked if he wants to save it. If he presses Y for yes, the preliminary diagnosis will be saved in the system memory. Pressing Command 18, which is Shift F6, will transfer the customer complaints on the preliminary diagnosis in the Service Advisor system to the customer service order form in Service Line. And it will bring the form up on the SAS screen for the advisor to complete. Complete instructions for filling out the CSO, including parts prices and labor rates, are included in the Service Line user manual. After the CSO is complete and has been checked, it's printed out on the SAS computer for the customer to sign. The Saturn Service Stall System, or SSS, is a computer-based diagnostic tool designed to help the service technician make faster, more accurate, and more detailed diagnoses of vehicle faults and problems in the engine, automatic transaxle, and anti-lock brake system. The heart of the service stall system is the computer terminal, which contains the SSS program, and which is mounted in a cabinet set on casters so it can be rolled around within the stall and between stalls. The system is also equipped with a remote entry device that allows the technician to operate the function keys from the vehicle without having to be at the keyboard during testing. The remote entry device consists of this handheld transmitter and a receiver mounted in the cabinet and connected to an antenna and to the computer terminal. The terminal is also connected to Service Line in the dealer host computer and is equipped with a modem that allows it to communicate directly with the Saturn Technical Assistance Center for direct vehicle or system diagnostic assistance. Under the computer terminal is a printer that can be used to print out hard copies of test data and information for reference. Data from the vehicle's onboard computers is read with the Portable Diagnostic Tool, or PDT, which is covered in detail in another part of this tape. The last piece of equipment in the service stall system is the Saturn Basic Engine Analyzer, or BEA. It functions like most other engine analyzers, allowing you to run, analyze, and replay cranking, charging, secondary ignition, and power contribution tests and results. The service stall system allows the technician to call up a preliminary diagnosis created by an advisor, to read the advisor's comments, identify a vehicle in a number of ways, edit a preliminary diagnosis, run a series of dynamic tests, read the inputs and outputs of the onboard computers as they are happening, use the basic engine analyzer to test engine functions, and perform a series of functional tests, all to help in making a faster, more accurate, detailed diagnosis so repairs can be made sooner and right the first time to achieve maximum customer satisfaction. The service stall system main menu shows 7 major items. You can make your selection in either of 2 ways. By pressing the number key for the number of the item, such as 4 for vehicle diagnosis, or by using the arrow keys to move the highlight bar to your selection and then pressing enter. The first step in using the SSS to repair a vehicle is to verify the malfunction, and the first step in that process is to identify the vehicle you're going to verify the malfunction on. So you begin by choosing Identify Vehicle from the main menu. This screen gives you 5 choices, 4 that relate to Saturn vehicles. Each choice you select will take you to an instruction screen. Selecting Read VIN from PCM, the powertrain control module, will show you instructions for hooking up the PDT. Select a VIN will list the vehicles you've worked on previously with the SSS for which there are still open service orders. And Enter VIN manually gives you this screen and a line to enter the VIN on. If you enter a VIN manually, you also have to enter the options on the vehicle before you can go back to the main menu. You can also identify the vehicle by choosing Select from Open CSO and then entering the vehicle you want to work on. When you've made your selection or completed entering a VIN, press Enter and you'll return to the main menu with the vehicle now identified. After you've identified the vehicle, the next step is to select Preliminary Diagnosis. This will show you the customer's name, the mileage, and the VIN. It also lets you review the customer complaints and comments entered by the service advisor, shows any codes or flags that were read during the advisor's PDT test, and also lists the possible causes of the customer complaint by fault groups. Within each fault group, it also shows the relative probability of each cause. In this instance, for example, there is a 74% chance that the cause of the engine overheating complaint is in the cooling fan circuit. Pressing function key number 8, or F8, will show more possible causes within the fault group. Pressing the F2 key will allow you to edit the complaint section. For example, you can add more complaints after a test drive of the vehicle. Editing the complaints may change the possible causes list, giving you additional clues to solving the problem. After you've reviewed the preliminary diagnosis, you're ready to go on to the next step, performing the initial checks. After reviewing the preliminary diagnosis, the next step in the diagnostic procedure is to make a quick series of initial checks and tests. These include a visual inspection for obvious problems that may create false or inaccurate test readings, such as loose or broken wires, or frayed insulation that can cause shorts, grounds, and blown fuses. Oil and coolant levels should be checked as well, particularly if there's an engine problem. You should also make a quick check of the controls to make sure everything is working correctly and there are no unreported trouble lights, and run through the shift cycle in idle, especially if there's a complaint related to the transmission. A test drive is also a good idea if there is any indication of a drivability problem in either the customer complaints or your initial checks. A good vehicle walk-around and checking of common and potential problem areas can frequently locate faults that are easily fixed that may have been overlooked in the service driveway or contributed to the fault readings during the advisor PDT tests. Regardless of the nature of a customer's complaint, this is always a good place to begin. The Portable Diagnostic Tool, or PDT, provides a way to plug into the onboard computers in the vehicle and read any diagnostic codes or information flags that have been set, as well as read many of the computer inputs and outputs as they are happening and record them. The PDT operates both as a standalone tool and as a communications link between the vehicle and the SSS. The first step in using the PDT is to select Portable Diagnostic Tool from the Service Stall System main menu. This will bring up the PDT menu on the screen. If this is the first test of the day, or it's been some time since the PDT was used, it's a good idea to start off by checking the software. You do this by selecting Item 4, Verify PDT Software. Before pressing Enter, make sure the PDT is fully connected to the terminal, turned on, and set to Main Menu. If the software is correct, the screen will say Current Software Loaded. If it isn't, you'll see this screen and should press Y to download the correct software. After the software has been verified, disconnect the diagnostic tool from the SSS terminal and plug it into the assembly line data link in the car. You can now use the up and down arrow keys on the PDT keyboard to select the tests you want to run. These include the Saturn Scanner Test, CVT Comprehensive Vehicle Test, ECM Service Stall, TCM Service Stall, and ABS Service Stall. You can also display results on the PDT screen or set up special tests that are described in the PDT User Guide. For this example, we'll select CVT, the Comprehensive Vehicle Test, which will be the one you'll run most frequently. This test will give you an overall look at the vehicle to start with and is recommended for verification of the repairs when you're finished. Notice that the first line on the PDT screen shows the vehicle condition or setup required to run the test. In this case, ignition on, engine off. Also the first instruction, push accelerator to floor and release. So start the test by turning on the key without starting the engine, and then push the accelerator to the floor and release it. This checks the battery voltage, coolant fan operation, and throttle position sensor. There won't be any display on these tests unless a failure is detected. When this data is entered, a Start the Engine message will appear. After the engine is running, the PDT will tell you to perform a series of switch tests, starting with the brake switch test, then cycling the air conditioning switch, and cycling the transaxle mode switch. If the PDT does not detect any of the switch actions, it will display a message like this: cycle the switch to continue the test, or press Enter to record a failure, then continue on. The comprehensive vehicle test includes power steering pressure switch and hand wheel sensor tests, a part throttle test that checks the block learn memory and canister purge, and a controlled RPM test in which the RPM is actually controlled by the PDT at approximately 2200. This test checks electromagnetic interference in the engine RPM, torque converter turbine, and vehicle speed signals. It also checks the oxygen sensor for a rich or lean condition. Again, unless one of the systems fails the test, there is no message on the screen. The CVT idle test checks the map sensor, electronic spark control, RPM signal, turbine speed signal, and if the conditions of closed loop and warm engine are met, the integrator. The final CVT test is jab throttle. This is an electronic spark control, or ESC, spark knock test, which requires a quick jab on the accelerator to raise the engine speed rapidly to 2500 RPM, and then a quick release. When the jab throttle test is completed, this message will appear on the PDT screen. After you've run the PDT tests you feel you need, plug the PDT into the terminal again and select number 1, Receive PDT Test Results, from the PDT menu. The screen will tell you when the transfer has been completed. At this point, the screen will automatically return to the PDT menu. Now select Display PDT Results. You will see the Results selection screen. Select the test you wish to display. This will show you the number of tests that were passed, failed, or were indeterminate. To view the actual tests that were run, press F3, indicated on the bottom of the screen as Continue. This shows you a list of the tests, identifying them by code number and name, and whether they passed, failed, or the results were indeterminate. To view all the tests, use the page down and page up keys. To look at the detail of a particular test, you can press the number or letter of that test, or move the cursor bar to highlight it and press Enter. This gives you the actual readouts of the test data. You can return to previous screens at any time by pressing the Escape key. As a result of your detailed PDT tests, you may want to change the preliminary diagnosis. You do this by returning to the PDT menu and selecting Item 6, Integrate Test Results with Diagnosis. This will display the tests that have been run, from which you can select the one you want to use to change the diagnosis. After making your selection, this test data will be integrated with the original test results, and a new preliminary diagnosis will be produced, along with whatever changes are appropriate in the fault groups and probable causes, which you can then check for possible repair. The service stall system provides you with a great deal of help in making a detailed diagnosis. It's actually a very flexible electronic toolbox of features designed to provide quick access to tests and information to help you isolate and identify the cause of a vehicle problem. It's been designed to work with you, the technician, using your expertise to form a diagnostic team. For this example, we'll begin by selecting a fault group to diagnose from the Vehicle Diagnosis option on the SSS main menu. Since fault groups are part of the vehicle diagnosis function, we select number 4, Vehicle Diagnosis. This shows you the subsystems listed from the top in the order of the most probable cause of a complaint. At this point, you have several options. You can select from one of the subsystems shown in the fault group displayed, or if you want to look at the complete subsystem list, you can select number 7. Notice on the bottom right that there are 8 pages of subsystems for you to choose from. This shows all the subsystems the SSS can help you diagnose. The list is specific to vehicle option content. If you want to look at the failures that correspond to different fault groups, you can push F4 from the vehicle diagnosis screen. This will bring up the list of failures corresponding to the fault groups shown in the vehicle diagnosis. From the vehicle diagnosis screen, you may want to review the results of tests which have already been run. As shown on the bottom of the screen, you can do this by pressing F6. At any time during the diagnosis process, if you have a screen that displays F5 bookmark in the lower right corner, you can press this key, which will give you a bookmark has been set message. Bookmark will save your place in vehicle diagnosis while you look for other information in SSS or work on another vehicle. When you select Vehicle Diagnosis from the SSS main menu, the fault group and subsystems shown on the first screen will match those on the preliminary diagnosis. That means Subsystem 1 of Fault Group 1 will have the highest probability of causing the malfunction related to the customer complaint and the test results. This makes it a pretty good place to start your diagnosis. Once a subsystem has been selected, in this case, Subsystem 1 of Fault Group 1, you will see the Subsystem Diagnosis screen, which gives you 5 choices. In addition to Functional Test, you have Diagnostic Help. These screens give you information to help you isolate components within a subsystem that may be malfunctioning. It also gives you the theory of operation, normal measurements, troubleshooting tips, possible causes of failure, and functional test descriptions. Along with the Diagnostic Help screen, you can also choose to look at a list of the components in any particular subsystem, in this case for the cooling fan circuit. This is a detailed list of the components that make up the subsystem, along with valuable information such as the circuit pin numbers at the PCM connector and the component harness. This can often give you valuable clues on where to look for the cause of the problem. The Tests Already Run option will display the same information as the Tests Run data from the vehicle diagnosis screen. It serves as a reference and a good reminder of what tests have been run previously and their results. Repair verification is used after the repairs have been completed. This will be covered later in the program. The primary purpose of this screen is to allow you to select a functional test for a subsystem. Functional tests are covered in the next section of this program. To perform a functional test with the service stall system, you begin by selecting Functional Test on the Subsystem Diagnosis screen. For this example, we've chosen the cooling fan circuit subsystem, which lets us demonstrate a variety of dynamic functions. The functional test selection will present an initial description screen describing the test for the subsystem, and in this case, telling you what action will be required. Along with the description, this screen gives you 5 options. You can press Escape to go back to the Subsystem Diagnosis menu. Get help with the system operation by pressing F1. You can get Topic Help by holding down the Shift key and then pressing F1. Topic Help gives you an index display that lets you access information and descriptions on any system feature, along with a listing of the diagnostic codes and their descriptions. F8 can be used at any time to quit the test, but it's usually used when you're finished to let the system know you're done. And F9 is used to redo a test for whatever reason. There are 3 types of functional tests: automatic, technician interactive, and text. The cooling fan circuit functional test incorporates both automatic and technician interactive types. When starting a test, you will normally press F3, Continue, to begin the process. This will cause a set of instructions to appear on the screen, such as we see here, telling you to hook up the PDT to the ALDL on the vehicle and to the computer terminal, verify that the PDT is turned on, and turn on the ignition key, but don't start the engine. The PDT acts as a communications link between the vehicle and the SSS terminal. During the first part of this test, the SSS will automatically provide a pass-fail reading on all PCM quad driver outputs. The cooling fan circuit is one of these. During the test, you will be asked to watch the telltale lights on the instrument panel, so you may want to use the SSS remote entry device from the driver's seat. Pressing F3 on the remote entry device changes the SSS screen, which tells you to watch for instrument panel lights, and listen for solenoid clicks. Pressing F3 again will cause the SSS to command the vehicle's PCM to cycle all the quad driver outputs of the quad driver module. The next screen will give you instructions on how to continue. In this case, since you saw the light and heard the solenoid, press F3 again to continue. This will show you the test results on each part of the quad driver circuit. Having verified the PCM quad driver part of the cooling fan circuit, you are instructed one more time to press F3. The screen now tells you to toggle the fan on and off by pressing the space bar and check to see if the fan's operation matches the status indication on the screen. This portion of the test verifies the cooling fan relay and motor. Notice also on this screen that the function key directions at the bottom of the screen have changed. Since the SSS can only command the PCM to turn the cooling fan on and off, it's up to you to determine whether it responded to those commands and to enter a pass or fail based on the fan operating as commanded. You do this by pressing either F4 for pass or F5 for fail. Since the fan did not operate properly, you press F5, and the screen indicates that the cooling fan circuit failed the functional test. Pressing F3 to continue the diagnosis will take you back to the subsystem diagnosis menu. Since the cooling fan circuit failed the functional test, selecting Diagnostic Help or the component list, along with the service manual, will give you the information you need to isolate the component at fault in the system that needs repair or replacement. For many of the functional tests, you will have to enter a pass or fail manually with the keyboard, as you just saw with the cooling fan circuit test. When a subsystem fails a test, that subsystem will remain on the list, but the probability percentage that it's the cause of the trouble will increase. This makes it a good candidate for repair or replacement. When a subsystem shown as a probable cause under a fault group passes a test, either automatically or by you, that subsystem is removed from the list, another subsystem becomes the number one probability, and the percentages change. When this happens, a functional test should be run on the subsystem that moved up to the top of the list. Functional tests can be performed for any vehicle subsystem that may cause a customer complaint in the areas of drivability, electrical, automatic transaxle, or anti-lock brakes. Some system tests using the service stall system require the use of the Saturn Basic Engine Analyzer. This gives the SSS the ability to monitor the performance of the engine, ignition system, and cranking charging system. There are two ways to enter the BEA program. The first is directly from the SSS main menu by simply selecting Basic Engine Analyzer. This brings up the BEA main menu, from which you can select the test you want to run. Choosing Cranking Charging Analysis, for example, will bring up the instruction screen for this test, which tells you to hook up the voltage clamps and the amp probe under the hood. On Saturn vehicles, the Basic Engine Analyzer is always used with the PDT hooked up to the car and the SSS terminal. This acts as a communications link between the vehicle systems and the SSS. With Cranking and Charging Analysis selected, when you engage the starter, the SSS disables the fuel system so the car won't start while it measures the cranking voltage. When it has completed taking the cranking readings, the SSS restores the fuel system, allowing the engine to start, and then measures generator output. On the Saturn service stall system, all the BEA readings are recorded by the computer and can be recalled at any time. If you select Analyze Secondary Ignition, you will see another instruction screen, which again tells you which leads to connect under the hood. Running this test can produce 3 different readings: kilovolt peaks, secondary ignition patterns, and cylinder miss recall. Again, all recorded for recall and analysis. Choosing Run Power Contribution Analysis will give you the Power Contribution menu. The BEA 6X Power Contribution Test is a way to determine quickly and accurately the individual contribution of each cylinder to overall engine performance. The test takes precise RPM measurements from the crank position sensor signal, then uses these readings to calculate power contribution. The 6X test determines whether a fault is due to a compression problem, such as valves or rings, or is combustion-related, such as a spark or fuel problem. The cylinder performance test gives you the percentage performance cylinder by cylinder. Selecting number 8, Monitor RPM Amps Volts, is a quick way to check the generator and battery condition. To review the results of the analyzer tests, select number 5, Review SBEA Analysis Results. This will bring up the Review Analysis Results menu, from which you can choose the test results you want to look at. These review screens show the detailed readings that were recorded in the computer, which you can read when you want to. And some tests can be printed out for future reference or to keep as a part of the permanent file on the vehicle. The basic engine analyzer tests, however, are not automatically integrated into the preliminary diagnosis. The Saturn Basic Engine Analyzer is a key part of the service stall system that lets you do a complete analysis on each vehicle and record the results of each test as you make it. When you're making a diagnosis, there may be times when you will want to watch the actions of various parts of a system in operation, much the same way you watch the spark action with the basic engine analyzer. The service stall system lets you do that using the dynamic display. You access the dynamic display through the SSS main menu by selecting number 3, Dynamic Display. This will bring up the dynamic display screen. Then by choosing View Serial Data, you will bring up the second dynamic display screen that will allow you to select the computer functions you want to see. If you choose number 1, PCM Engine Controls, you will get a listing of data tables. Since the computer reads the data from the vehicle computers through the PDT, if you have not already done so, this is the time to hook it up to the SSS terminal and to the car and turn on the ignition key. Now you can choose one of the tables to observe. In this case, we picked General Information, so you'll want the vehicle running. This shows you what's happening in the engine as it happens, or dynamically. The service manual has a page showing this same table with the normal values for each item when the engine is running properly at idle, so you can compare them. If you want to isolate or highlight any of the readings on the screen to make them easier to find and read, you can press F4, Highlight Data. This removes the readings from the screen and creates a highlight bar. Then by using the cursor position arrows, you can move the highlight bar to the readings you want to see, and by hitting the space bar, they will be restored and highlighted. Pressing the space bar a second time at a highlighted position will remove the highlight. You can save the highlighted readings by pressing Enter. To look at a different set of data, simply press Escape to go back to the list of tables. To choose a different system to observe, press Escape one more time. Pressing Escape a third time will return the screen to the dynamic display menu, where you can select another important capability of the system, View Snapshot Data. To observe faults or problems that only occur under certain driving conditions, or to help locate intermittent faults, the PDT can be used to record data from the onboard computers while the car's running or being driven on a test drive. There are a number of ways to set up the PDT to record a data stream, depending on the system you want to check. The PDT User Guide explains how to do this. To watch the data once it's been recorded, you select 2, View Snapshot Data on the Dynamic Display main menu. This will instruct you to hook up the PDT to the SSS terminal. When this is done, press the F3 key to continue, and you will see the snapshot frames in continuous mode. Pressing the up or down arrows will speed up or slow down the viewing rate. Pressing the left arrow will let you view the frames backwards, and the right arrow moves them forward again. Pressing the F3 key again will stop the continuous mode and allow you to view the frames one at a time. Pressing the right arrow will advance the frames, and the left arrow will move them backwards. Pressing Home will move the display to the trigger frame of the data where you began recording, and End will move it to the last frame. Pressing Escape at any time will return you to the dynamic display menu. The snapshot capability of the dynamic display is particularly helpful in finding intermittent problems. Once you've identified the subsystem which is the source of a complaint or problem, the service stall system has pretty much done its job and you have to make the repairs. This process is not much different from repairing any other car, except in those areas unique to Saturn that require special tools and equipment. all of which are covered in the service manual. The SSS can help make the repair process quicker and easier by providing information that will help you isolate a component at fault, such as the component list in Diagnostic Help. Used in conjunction with the service manual, which also includes detailed diagnostic information, it can be a great help. When the powertrain control module or ABS control module has to be replaced in a Saturn vehicle, a special procedure is required. These modules contain electronically erasable programmable read-only memory chips or EEPROMs in place of the fixed memory PROMs used in other vehicle control modules. As a result, the EEPROM has to be programmed when a new control module is installed. This can be done either at the service stall or in the car. It's normally done with the PCM in the car. To do this, first plug the PDT into the vehicle. Then call up the SSS main menu on the screen with the vehicle identified. Then select item 7, System Utilities, and press Enter. On the System Utilities menu, select EEPROM Reprogramming by putting the highlight bar on 1 and pressing Enter. For this example, we are replacing a PCM, so on the reprogramming screen we select PCM Replacement Procedures. This brings up an information screen that explains the procedure. It will ask you to verify that the information the SSS has read from the current PCM is correct. If it's not, you press N for No, and it will ask you to enter the correct information. If the original PCM were completely inoperative, you would also have to enter the VIN, options, and tire size manually. In this case, it is correct, so you press Y for yes. This brings up the next instruction screen, and you press F3 to continue. This screen refers you to the service manual for the procedure to replace the PCM. After replacing the PCM, pressing F3 will take you back to the EEPROM reprogramming screen, and the new PCM is ready to function. After your repair work is all completed, there is still one more step before the car can be returned to the owner. You should verify that the repairs are complete and successful. When you feel you have completed all the repairs, the next step is to verify those repairs. With the PDT hooked up to the vehicle and the SSS terminal, start with the system main menu with the vehicle identified and select number 4, Vehicle Diagnosis. On the Vehicle Diagnosis screen, select the subsystem that was shown in the preliminary diagnosis that you worked on, in this case, the cooling fan circuit. This will bring up the repair verification screen. The first item on this screen is Clear Malfunction Codes. Press Enter to clear codes, and you will see the Clear Malfunction Codes screen. By using the function keys shown at the bottom of the screen, you can clear the codes from each computer module individually, or by pressing F7, clear all the codes at once. When the codes have been cleared, press Escape to return to the test menu. This time select Functional Test, and repeat the functional test for the subsystem that had failed originally. Before turning in the customer service order, however, and considering the job finished, you should make one more complete visual inspection. This should be for both repaired items and for the general condition of the vehicle to make sure it's in the same condition you'd want to receive a car back yourself. The ultimate goal is the complete satisfaction of every Saturn owner and customer, and in this, as in so many other activities, neatness counts. The Saturn service stall system can help you a great deal, but the most important element in the whole process is still you, the caring, competent, and experienced technician, and the final responsibility is still yours.